Hi, Mr. West. This is my second CPT recording, and I did option number 2, the question about complete inelastic collisions. So I have had to retake this a couple of times because I'm talking too much, so I'm just going to get right to it. The question gives you a mass for the first object of 0.6 kilograms, mass of the second object as 4.4 kilograms. Velocity of the first object is 32.4 meters per second to the right. This is only in one dimension. Velocity of the second object is 8.6 meters per second left. Following that, I want my directions. I'm just going to write them up here. That's still in frame. Up and right are positive. So there's three formulas I'm going to use. First one is kinetic energy lost is equal to initial kinetic energy minus final kinetic energy. Second one is just equation for kinetic energy, which is just 1/2 mass times velocity squared. My last one is for collisions, for final velocity. And that's equal to mass 1 times velocity 1 plus mass 2 times velocity 2 divided by mass 1 plus mass 2. So, sure, if you want to pause the video, right here is where it has been completely derived. Going back, we're now going to solve for initial kinetic energy. So EK initial is 1/2 times mass 1 times velocity 1 squared plus 1/2 times mass 2 times velocity 2 squared. And so that ends up being 477.64 joules. Energy is scalar, so no direction is needed. And so now we're going to find final kinetic energy. So because they both are have the same final velocity, we can factor this. And I'm just going to show you with this. Pull out the 1/2 from both and pull out the velocity from both because it's the same velocity. So that leaves us with the equation 1/2 times mass 1 plus mass 2 times velocity final squared. I just like keeping it in the same order. I could have brought the final velocity to this side. And so we don't have final velocity, but I'm just going to show this 0.6 plus 4.4, which is 5 velocity final squared. So to find final velocity, we're going to use the equation up here. Let's write this in, velocity final. I'm just going to write in numbers because you can see it up here. So 0.6 times 32.4. Directions matter here. So just to specify that, plus 4.4 times negative 8.6. Then divide this all by 0.6 plus 4.4, which again is 5. And that gives me a final velocity of negative 3.68 meters per second. So that's telling me my final velocity is going to the left, west, same thing for me. So we're going to plug this back in. I can ignore the negative and say it's heading to the left. But since energy is scalar, the direction doesn't really matter. So we're going to apply that in again. 1/2 times, simplify this to 5 times 3.68 squared. And that gives me 33.865 joules. Don't forget to write the unit. So we have our initial and final, and now we have to find how much was lost. So we're going to use the formula up there. Kinetic energy lost is equal to initial kinetic minus final kinetic energy. So that's equal to 477.64 4.64 joules minus 33.865 joules. And that ends up being 443.78 joules. So that's how much was lost when the two balls collided. Last thing is just a therefore statement for the question. So therefore, the balls lost. We can use scientific notation. 4.4. It's going to be 4 because it rounds, times 10 to the 2 joules. After the collision. And that's it. That's everything this question is asked for. Thank you for watching. See you in the next one.